All right, enough superhero puns. My name is Nick Maludy. I'm a software engineer. I'm a husband. I'm a father to two crazy little girls, and I specialize in research software and taking that research and that idea in someone's head and making it tangible and reproducible and putting it into the actual world and deploying it live. So today, talking about self-signed certificates and how we can fix that problem, I'm going to go through what happens in a self-signed certificate workflow. Basically, you have an application or a browser that's going to talk to a web service, and it initiates communication over HTTP and tries to establish an HTTPS connection. It sends out a message, and that server responds back with its public key or its certificate. The application or the browser then checks that certificate against its list of known certificate authorities that it holds on that host. And if the public key doesn't match any of the CAs using some cryptographic magic, which we're not going to get into, if it can't trust any, or if it doesn't match any of those CAs, it's going to go ahead and say that it's not verified or valid, and it's going to give you the red X in your browser. What we want to have happen is a similar sort of flow where the application or the browser sends a message, the response comes back with a public key, and we can actually verify that public key against the known CAs. And that happens with a technique called PKI, or public key infrastructure. And that's really the practice of taking SSL certificates, signing them with the central authority, and then distributing out those certificates to the hosts that need them, as well as the CA certificates that are needed to be verified by the clients. And so what does this look like if you're actually trying to do it? What are the steps that are required? So say you have a couple of hosts, a Linux and a Windows host, and a couple clients, and then a CA. Your CA, in our case, was a Windows host. It was a VM that was usually kept offline, turned off, and we'd have to go turn it back on in the case that we wanted to go sign a new certificate. So on the host, you would create what's called a CSR, a certificate signing request. This is just a special text file that contains some things like the host name, the name of the organization, maybe some emails, some other properties of the certificate that we wanted to embed within it cryptographically. And at the same time, it also creates a private key, which the server holds on to. The admin would then take that CSR, log into the box, grab it off, or generate it, grab it off, and then copy it over to the Windows host, usually manually or with a CIFS share or something like that. You would then take the CSR and run a command to go and sign the CSR and generate a public certificate for each one of those hosts. That public certificate would then need to be copied off and then pushed out to the servers where the CSR was originated. And that sits right next to your private key. Finally, you're going to go ahead and copy the public part of the root certificate to all the hosts, to both the servers and the clients. Again, another manual step.
Hey, Nick, sorry
Yes.
to interrupt. I know we're recording. We can't see your screen, your shared screen.
Okay.
Thank you, YouTubers, for letting me know. There we go. I can see it just fine now. Thank you.
All right. Oh, well, hopefully I don't, there's a lot of steps there that I probably glazed over, but what you're looking at, we've got our servers that have our private and public keys, as well as our CSR, our certificate signing request, and our root certificates. And then we've taken our services, Apache, Nginx, and IIS, whatever our web servers are, applications, and then pointed them at those certificate files that live on disk, or in the case of Windows, in the certificate store. And because these certificates are signed with the root CA, and that root CA certificate is propagated on all the clients, when they go and create their HTTPS connection, they'll be able to validate that those servers, or verify that the servers are who they say they are. And so this is what it looks like old school, and this is what we used to do manually. And obviously, manual is not a good place to be, and so we want to try to improve upon the situation. So what ends up happening in this scenario, properly signed certs are painful, right? It would take, say, 30 minutes or so to sign a single certificate and distribute that back onto the host and bounce the service, right? Just a lot of time. And so what ends up happening, you get the Oprah effect, right? Self-signed certificate for you, one for you, one for you, self-signed certificates for everybody. And you end up not having any trust between your clients and your servers. And so you end up disabling validation or verification, so you can actually create HTTPS connections. And that leaves you vulnerable to man-in-the-middle attacks, where someone can sit in between the client and the server, impersonate the server, and because you're not validating or verifying that identity correctly, that middleman can then intercept the traffic and create fake responses, and it's not a good security practice. The other problem is around renewals, right? So periodically, it was usually about once a month, our security team would go out and scan the internal environment and say, hey, whose certificates are expired? And our certificates that we provisioned usually lasted about a year when we did it manually. And so every year, every month, you'd have some certificates that expired, were created a year ago and they expired this month. And you'd say have maybe about 40 or 50 certificates you had to go roll and refresh. And no one likes getting ServiceNow emails. No one likes working ServiceNow tickets. And we just not a good place to be in. We wanted to try to improve that situation and see if we could reduce the toil, because there's no real value in a human going and doing this manual action. So we sent out a call for help, right? We sat down with the security team and with the DevOps folks and said, hey, what does each side of the table want? On the security side, we wanted certificates to be properly signed with the central CA. They wanted to have clients enable validation of their SSL communications and also upgrade the ciphers that we were using. We were using some old ciphers and some smaller key sizes. We wanted to improve that situation and have a policy that all the certificates that were created met that certain standard. On the DevOps side, we wanted to automate the renewal process. So we didn't want to have a human in the loop every time we needed to renew a cert. It also needed to work cross-platform. I'm talking about real world here. And so a lot of the clients that we worked with and the servers that we managed were just plain Linux VMs and Windows VMs that need to work on both those systems. And similarly, and probably the final piece was to tie it together, right? When we refreshed a service, we wanted to automatically reload the web server that it was attached to, or the application that it was attached to. We didn't want a human in the loop having to bounce something or restart something or anything like that. It should just all be transparent and handled at the time of renewal. So the form of justice came in the form of HashiCorp Vault and Puppet. We use HashiCorp Vault as our PKI store, right? It generates and stores all of our certificates using the REST API. So to facilitate that, we're using the PKI secrets engine, which you can configure within Vault itself. And then on the application side and the distribution side, we're using Puppet. So Puppet is our tool of choice for configuration management. And we use it to distribute the root and intermediate CAs, as well as run the code to actually generate and make the API calls to Vault to create our certificates and renew them and revoke them. To facilitate that, we created our own module called Encore Vault, which is available on the Forge and our GitHub URL here on the screen. And that provides a Puppet resource called Vault_cert, which you're going to see a lot in the code coming up. So what does PKI look like with Vault and Puppet integrated together? So this is going to be the transformation or the high-level overview from what we saw earlier. So we still have our root CA. It's still a Windows host. And this time we can keep it offline because we only really need it to create a signed intermediate CA, which has signing authority that we inject into the Vault PKI engine, the secrets engine. From there, we have a Puppet server, and we copy both the public part of the root CA as well as the public part of the Vault intermediate CA onto the Puppet server. And we're going to use Puppet to then distribute those CA certificates to all the clients and the servers. So you've got clients and servers that are running Puppet to go ahead and facilitate the distribution. The agents on those hosts execute, and they check in. The Puppet server responds back with a catalog that contains the CA certificates and places them in the right spots on the respective file systems. And then the agents on the server side, when they that are running web servers, need to go and request new certificates. They make API calls to Vault using the Vault_cert resource. That resource responds back with, receives the API call response, which contains the certificate and the public key, and we write those down to the file system as well. And then Puppet configures, the web server, either Apache, Nginx, IIS, Java, whatever web server you have, to bind to those certificates, and calls a refresh or a reload whenever they change. So what happens under the hood in this Puppet resource that we created? The first thing we do is we read the certificate from the file system and check to see if it's going to expire within the TTL that's configured. The default TTL we have is 3 hours. So if the certificate is going to expire in the next 3 hours, we're going to go ahead and revoke it and renew it. You can configure that to be as many hours or minutes as you like. The next step we're going to take, if the cert is not expired, we're going to check for revocation. So we actually make an API call out to Vault and pull the certificate based on its serial number and say, hey, is this certificate expired or not expired? And there's part of the API response that it gives us back. If it's time to actually renew the certificate, we're going to revoke the old one so it's no longer valid. We're going to, via an API call to Vault, we're going to make another API call to Vault to create a new certificate. That responds back with the certificate and the public key, or the private key, I'm sorry, that comes from the Vault API. And then we write that to the file system and bounce the service, whether that's Apache, Nginx, IIS. So what does this look like in the code? This is Puppet code. It's called a Puppet manifest. And in its simplest form, it is a Vault cert resource, and we give it the name of the certificate. In this case, it's called Synapse, which is a matrix chat server implementation. And we tell it the directory that we want those certificates and those private keys to land in. And then the fourth line down is a notify, which sends a refresh notification to the Nginx service to tell it to reload itself whenever this Vault cert resource changes. And so kind of walking through this step by step, we have a Linux host with a Puppet agent on it and a Vault server running. The first step is the Puppet agent kicks off and it runs and it calls this Vault cert resource. The Vault cert resource behind the scenes sends out our CSR API call to the Vault server. It responds back with a cert and a key in the API response. The resource then writes that information to the spot on the file system that's configured in the inputs. And then finally, that service notifies the Nginx server to go ahead and reload. And you can see there at the bottom, the Nginx server is configured with the same path information. So it's reading the same path place. And when the server goes and reloads, it reads the new certificate from the file system. So before I continue on, we're going to talk a little bit, just a high level about Puppet and how it works, so you can have some better context on some of the more advanced things I'm going to talk about in the future. So the first part of a Puppet run is the agent kicks off on a timer. By default, that timer is every 30 minutes. The Puppet agent wakes up and it collects some facts about the host, things like the host name, the IP address, the disk information, maybe the AWS region that it's living in, etc. It sends those facts to the Puppet server. The Puppet server then receives the facts and compiles what's called a catalog. It takes the code that we wrote in that last slide and compiles this JSON catalog that describes the desired state of what we want the agent to go and execute. That catalog is then encrypted and sent back to the agent. The agent takes that JSON catalog and runs it through its agent process to go and apply the desired state. And then finally, based on any changes or errors that happen, it sends a report back to the server, and the server stores that report in the PuppetDB database. It's a Postgres database. And really what I'm trying to highlight here is, one, the process, but two, the fact that there's some things that can run on the agent side and there's other things that run on the server side, and that's going to be important in the next couple of slides. So the demo, or the code that we just showed you, was for Linux hosts. On Windows, we have a little bit different of a challenge. On Linux, we can tell the Vault cert resource to save the certificate at a certain spot on the file system, and that's great. And we can then bind our services to that location on the file system to go and read the certificates. The problem with Windows is that this place in the file system that these things are referenced contains a unique identifier at the very last part of its file path. So the very end piece, the last part of the file name, is actually a unique thumbprint. It's a hash of the public certificate, and that's only known once it's created. The problem here is that we don't know, the services don't know what that certificate hash is before they run. because the Vault Cert resource actually runs on the agent side. And so when the server is compiling the catalog, there's no way to output that data on the agent side and have it get piped into the IIS binding in this case. And so there needs to be a way to have that data available before it gets sent to the agent so that it has all the proper details that it needs to both create the certificate as well as bind the services. The solution here is to use a function. So functions occur, or they're run on the server when the catalog is getting compiled. And you can then, so that in our case, the function is going to actually make the API calls to Vault to check everything out, make sure it's okay, generate new certificates if they need to be renewed, and then embed those certificates into the catalog and send that to the agent. And the agent, when it's executing the code in the manifests, it will have, executing the catalog, it'll have the thumbprints and the unique path to go ahead and do the proper binding. So here's what the code of what it looks like on the Windows side. In this case, we have a Vault Cert resource and an IIS binding for Chocolatey. Chocolatey is a package manager for Windows that kind of wraps MSIs and EXEs. It's awesome. If you haven't used it, you're a Windows person, check it out. The real difference between this code and the Linux code is the line at the top where we call the vault : cert function. I'm going to walk you through the steps here of what happens in the communication paths. So the first step from the Windows server side is the Puppet agent wakes up, it collects its facts and reports them to the server. The Puppet server, using the vault cert function, creates the CSR and sends that to Vault. That certificate and key in the API response are returned in this cert output variable that you see there. That variable is then embedded in the catalog that the Puppet server is creating when it's executing. We then ship the catalog down to the agent that's running on Windows, and the Windows agent then calls in our Vault Cert resource, and that contains, again, the certificate and the private key, and the resource knows to write that to the correct spot on the file system. In this case, it's the Windows Certificate Store, which is like a special cert : area on the file system on Windows. And the final piece is that we call our IIS binding, where we have the thumbprint that was embedded in the catalog, and we can tell IIS to bind to that thumbprint. And now we've got a properly configured IIS instance that has our centrally signed certificate from Vault. One other note here, the IIS binding resource will automatically restart or reload the IIS instance or the IIS site whenever that certificate hash changes. So that's handled behind the scenes for us automatically. We don't need to notify in this case. The other interesting thing that I learned, because I'm not a Windows person, but I was working alongside some of our Windows admins while doing this, they had the concept that they called a machine certificate. So traditionally in the Windows world, you would go and provision a single certificate with the host name of that machine, and all of the services that run on that machine would bind to that single certificate, which is fine. And so we created a pattern around that, which we called our machine cert profile. It just contains a single Vault Cert resource, and then other places in our Puppet code can reference that same certificate thumbprint and use it to bind to that same area in the certificate store. So in the top is where we're defining our machine certificate that's static and as a single instance. And on the bottom, we're defining our WinRM binding as well as our IIS binding for Chocolatey that reference the exact same certificate that was created for our machine. Now that we have our certificates for the services deployed, we also need to deploy the CA certificates so that clients can trust the servers that they're communicating with. In this case, we're going to show you how it works on Windows, and then the next slide we'll go ahead and show you how it works on Windows. On Linux, it's pretty easy. We have our Puppet agent that kicks off, reports our facts again. It compiles the catalog, and during the catalog compilation, it's able to look up some data in what's called hira, which is a hierarchy of data. By default, it's YAML, but it can be lots of other things. You can talk out to a Postgres database, ServiceNow. You can talk out to anything you want, right? It can be it's a totally flexible and pluggable system, but by default, we embed things in some YAML data. And the YAML data on the left contains our example Vault certificate for our Vault CA. And if you can imagine a root CA, I didn't have enough space on the screen, but we could have multiple certificates defined there and have them all embedded in the catalog. That catalog then gets returned to the Puppet agent. And when we go and apply that catalog on the host, it runs through these trusted CA resources, and those simply put them in the right spot on the file system depending on your OS. On Red Hat, it's etc PKI TLS CA, I believe, is the path, and then runs a command to regenerate the central CA file for that host. So it's now a trusted system certificate authority that's able to be used and verified by all the services. So things like Chrome or Firefox all would trust the certificate and be able to utilize it. On the Windows side, a little bit more complex, again, due to the problem that Windows has with its thumbprints, but similar sort of concept. The Windows Puppet agent kicks off, sends its fax. We read the certificates from hira from the YAML data and embed them in the catalog. That gets distributed out to all the agents. The agents run, and we extract the certificate details from the raw data. Basically, we read in the raw certificate content, and we do an X509 parse, and we pull out the thumbprint information off of it, and then use that to write that data to the file system and bind any services or install them into the centralized certificate authority. So what have we shown here today? We've shown that the dynamic duo of Vault and Puppet have been able to centrally sign and distribute both SSL certificates as well as CA certificates out to all of the hosts that are in the infrastructure. We showed how you can bind services and automatically refresh them when a cert changes. So again, when Apache or Nginx needs to get reloaded, when the cert changes every so often, whatever the TTL is, that automatically happens rather than having a human in the loop. And in our case, when we were deploying this, we ran it on about 500 servers in production, and we turned on a TTL of 30 days. And when it rolled out, we did it on like a Thursday at 1 p.m. Puppet default runs every 30 minutes. And so it deployed out to all the servers over 30 minutes. We noticed no downtime, no hiccups, no outages at all. And then after the 30 days, we waited and all the certificates automatically renewed, no issues at all. And it continued like that until I left the company. The result is that from a client-side perspective, we've been able to turn on SSL validation and verification and have truly secured and validated, verified connections between clients and servers. So where are we going from here, or where am I going? I have alluded to the fact that I've left the company that I was working for when I wrote this talk and was working on this this project. I've been transitioning into an HPC environment, high performance computing, and been taking some of these concepts and going to be applying DevOps in that space, as well as working on some GPU algorithms, C++, kind of lower level programming and computing, but still taking with me the things I learned from an enterprise IT perspective. I appreciate the time. Thanks for tuning in. I'll hang out in the YouTube chat if anyone's interested, wants to talk SSL or certificates or Vault or Puppet, as well as anyone that's kind of in the new space that I'm going towards on the HPC environment. Love to geek out and share my thoughts and ideas with anyone. Thank you very much.